Welcome everybody. This video I'll discuss about the final exam. So I'll give some important hints about final exam. So in final exam you will get 6 questions. So one question will be including the RC and RL circuit, first order RC and RL circuit, and the second question and another question will be nodal analysis, one question from mesh analysis, one question from Thevenin theorem, one question from superposition, and one question from the power analysis. So basically the Thevenin theorem might ask you apply superposition theorem for solving a circuit or so finding the B Thevenin. So let us give some type of typical, give some idea about typical exam question. I would like to start from the AC power analysis question. So AC power analysis question. So you'll get one question from AC power analysis. So in this, let's say you need to practice some question, some type of question like this. So let's say we have a circuit. Having 3 loads. So think about this load or this branch has 2 kilowatt and takes power factor is 0.8 lagging, and let's assume this is the power of this is 3 kilowatt and power factor is 0.6 lagging. And the power of this is given like say 1 kilowatt and the power factor is 0.6 leading, and you need to find the voltage, supply voltage and the supply current, and also the voltage over here is given. Let's say this voltage is 100 volt, angle 0 degrees, and this value given in RMS. So now if this information is given, then how we can find the Vs? So we need to find Vs, the supply current Is, and let's say overall power factor. So now if you think about this load, let's assume this is Z1, Z2 and this is Z3. So for Z1 we get 2 kilowatt. This is the real power and power factor is this. So if I start with the power diagram like this, so this is 2 kilowatt and power factor cosine theta is equal to 0.8. So you can find the angle. The angle is 36.86 or 87 degrees. So let me draw this. It is lagging, so I should draw on the top. So this is 36.87. Now if you want to find this power, apparent power, and also the reactive power Q, so this is P. So S will be P over cosine theta. So P is 2 kilowatt and cosine theta is 0.8. So it will be 2.5 kVA. You also can find Q if you want. Q will be S sin theta. So S is 2.5 and sine 36.87 degree. So it will be 1.5 kVAR. Similarly for load 2, so this is for Z1. Similarly for Z2, if you draw the power triangle, you'll see this is 3 kilowatt and the angle, so cosine inverse 0.6 is the angle. So it is 53. So theta equal to 53.13 degrees. So I get this 53.13. So now if I want to find this value S, so this is S1 Q1. So if I want to find so you'll get S2 is equal to 3 over 0.6. So 5 kVA. And Q2, just I would like to show you Q2. However, we don't need all of this information. So this will be S2 sine 53.13 kVAR. So that becomes 5 so 4. Now, as you know, S1 is equal to V1 I1. S is V ampere, volt ampere, so it will be the product of V and I. So we have to find I. So we can find I1 will be S is S1 is 2.5 and V is 100. So you can want to count 250 ampere. Now it gives us only the magnitude of I, not the phasor, not the phase angle. So the phase angle of I will be 250 and the phase angle will be, you see the angle here, the power factor angle is the angle between voltage and current. So here the voltage angle is 0, so current will be negative 36.87 degrees. Similarly, we can find S2. From S2 we can find V2 times I2. So you can find I2 will be S2 is 5 times 1000 and voltage is 100. Sorry, this will be 2 25. So 100, and so I write the magnitude only, so it will be 50 ampere. So now if I want to find the phasor form, so that will be 50, and the angle is negative 53.13. So now I got I1 and I2. So if I add I1 and I2, we'll get IS, because IS is the sum of I1 and I2. So from this we'll get IS equal to I1 plus I2, and where I1 is 25 and angle is negative 36.87, and I2 is 50 and angle is negative 53.13. So if I add them, you will get, so let me take at 25, the angle is negative 36.87 plus 50, angle is negative 53.13. So this one, so it will get, let me find in polar form, so it will be 74.33, and shift angle is negative 47.72. So this is my IS. So this is one of my answer, IS equal to this. Now we need to find Vs. So to find Vs, we need the voltage drop of Z3. So Z3 got, the real power of Z3, P equal to Vi cosine theta. So here you see V, we don't know the V. I is 74.33, and cosine, the angle here is 0.6. So cosine theta equal to 0.6. Basically this cosine theta. So V equal to 1000 V times 74.33 times 0.6. So now we can find V equal to 1000 74.33 times 0.6. So that gives us 22.42 volt. And theta is the power factor angle. So theta equal to theta V minus theta I. So here current is leading, so theta I will have the higher angle than theta V. So we should write it like, theta equal to theta I minus theta V. So now the theta power factor angle is theta. So theta equal to cosine inverse 0.6. So that is 53.13 degree. So now 53.13 is theta I, the current angle, we already know it, negative 47.72 minus theta V. So theta V will be 53.13 plus 47.72. So this is 53.13 plus 47.72. That gives us negative 185. So we'll get V of Z3 is equal to 22.42. Angle is negative. Good. So now Vs is the voltage over here plus the voltage of Z3. So 100, 0 plus 22.42. Angle of 100.85. So if I add this, you'll get 100 plus 22.42. Angle is negative 0.85. I will do it in polar form, so it will be 98.278. I am sure. So 100 plus 22.42 shift angle minus 100.85. 98.287, and the angle is negative 12.947. So this is the voltage. So now we got Vs, and the angle of Vs is this, and Is got this angle. So you will get power factor is cosine theta V minus theta I. So cosine theta V is negative 12.947 and theta I is negative 47.72. So this is negative 12.947 plus 47.72. So cosine 34.773. And as you see, the Vs got higher angle than Is. It is the value angle is negative, and this is also more negative. So theta V, V voltage angle, voltage lead the current. So at voltage lead the current, so it will be lagging power factor. So if I find the power factor, that is 0.82 and lagging. So this is the supply voltage, and this is the overall power factor. So you should mention the power factor type, lagging or leading, in your answer. Well, let us solve another example. we need to solve this circuit using nodal and mesh analysis. So let me solve this circuit using nodal analysis. Then I will repeat my work for mesh analysis too. So to solve this circuit is nodal and mesh analysis. I would like to do some modification on this circuit. Like at first I will convert this time domain to frequency domain, and also I'll combine this simple impedance together, like these are in series. So combine these three are in series, we'll combine them together. So let me redraw the circuit. So it will be 20, and this is 60° negative, and also this value. Then I make it so at first you see here we have 1 millifarad. So the impedance of this will be, let's say Z1 is negative J omega. Omega is 100 and C is 1 millifarad. So 10 to the power negative 3. So that will be negative Z10 ohms. So I write it like 2 minus Z10. And then this one Z2 is J omega L. So J omega is 100 and L is 20 times 10 to the power negative 3. So this will be J2 ohms. So I write it J2 ohms. This value is Ix. So I write it like Ix. And this in frequency domain there will be 2 cosine angle 30 degrees, and here we have 40. So Z3 is 40 J omega, and 40 times 10 to the power negative 3. So that will be J4, and Z4 is negative J 100 times 2 times 10 to the minus 3. So that will be 5. So now this is basically, this branch will be 5 plus J4 minus J5. Simply we can write 5 minus J1. So write it like 5 minus J1. And this value is 2Ix. So I prepared the circuit. Now we can apply nodal analysis or mesh analysis over here. So let me start with mesh analysis. So if I write mesh current method, so for mesh current method I need to assign a current here. Let's say I1. I use uppercase I. I2, and here I3. So if I write mesh equations now, so from here this will be negative 20 minus 60, and this impedance 2Z10 times I1, and here will be plus J2 I1 minus I2 equal to 0. But For this mesh, we do have a current source between two mesh. So this is a basically super mesh. So I have a super mesh here. So if you have a super mesh, then we can and this basically this mesh current is connected with only one mesh, right? So we can simply write I2 equal to 2 angle 30 degrees. So I2 is, right away we know the value for I2, and then for this mesh we can write 5 minus J1 I3 minus I2 plus 2ix equal to 0. Here you see 2ix is voltage, not 2ix is not current. So it is a dependent voltage source. So the value labeled here is the voltage value. So 2ix, don't be mistaken that it is a current. No, it is not a current, it is a voltage. 2ix. So it's a voltage. So now we also need to find what is the value for ix. So ix is the current of this component. Basically the current of this component will be I1 minus I2, because I1 is the same to this ix and I2 is opposite to the ix. So ix will be I1, that is opposing by I2. So now if I want to simplify these equations, you can write it like 2 minus J10 minus J8 I1, then J2 I2 equal to 2060, and I2 is given, so I2 is known, so you can write 2 minus J8 I1 equal to 2060 plus J2 times 2 angle 30. So you can find I1 from this expression. So you can solve for I1. I don't want to show you, so but you can do it. Then for this, from this equation, you can write 5 minus J1 I3, 5 minus J1 I2 is equal to 230 angle 30, and plus 2 ix is equal to I1. Then I1 we already found here, so plug in the I1 in this equation, and I2 you already know that, so put I2 here. Then if you replace I1 with the value you already compute here, and the I2 that we got in this over here, then you can easily find I3. So this is how we can find mesh current. If you want to find the circuit current Ix, the Ix expression you already know, I1 minus I2. You can do this. Now I want to solve this very same circuit using nodal analysis. So if I want to solve using nodal analysis or node voltage method, then you have to use a reference node here, and once you take reference node, you know the voltage of this point is known, 20 negative 60. This will be an unknown point V1, and the voltage of this node will be V2, and V2 is also 2Ix. So now let me write the node voltage equations. So it will be V1 minus 20 angle 60 over 2 minus J10, the current over here, and V1 over J2, and the outgoing current is 230 equal to 0. Now for this node we can write V2 over 5 minus J1 and okay, so here we can write V2 equal to 2Ix. V2 equal to 2Ix, because this is a voltage source here, so this voltage will be 2Ix, and Ix is V1 over J2. V1 over J2. So now you can write V2 equal to V1 over J2 times 2. So negative J V1. So just solve this equation, and if you solve this equation and find V1, then you multiply V1 with negative J, you will get V2. So these are the node voltages. Now if you want to find Ix will be V1 over J2. So you can find Ix, the current over here. Let me solve another example. So let us think about a circuit like this. So let's say this is 10, this is J10, this is 4, this is J4, and this is 6, this is minus J6, this is 20, and this is J20. So you need to find Thevenin voltage from the terminals AB, and also the Thevenin impedance from terminal AB, and you also need to find the ZL for P max, and what is the value for PL max. So to find this, I could redraw the circuit, because we can simplify or combine these impedances together. So it will be 100 angle 0, and this is 10 plus J10, and here we can write it 4 plus J4, and here we can write this is 20 plus J20, and I open up this terminal AB to find the B Thevenin. So here the 6 and J6 in parallel, so the impedance will be 6 times negative J6, 6 plus minus J6. So if I find it, it will be 6 times 6I negative 6I divided by 6 minus 6I. So it goes 3 minus J3. This is 1045. So we can apply superposition principle. So for superposition technique, we need to consider this volt source acts alone. So I remove this, replace this with a zero current source. So it is 4 plus J4, 3 minus J3, 20 plus J20, 10 plus J10. Now if you want to find the voltage here, so you might need to find the total impedance of this circuit. So let's to find the total impedance. So these two will be in series. So 3 minus J3 plus 20 plus J20. So that gives us 23 minus J17. And this will be parallel with 4J4. So this will be parallel with 4 plus J4. J4. So if you find this, so just you can do it like this way: 23 minus 17 I inverse plus 4 plus 4I inverse, then inverse again. So we are getting 4.46 plus J 3.3037, and that will be in series with 10 plus J10, 10 plus J10. So that will be in series with 10 plus J10, in series with 10 plus J10. So just then it will be 14 plus 46 plus J1307. Now we can find the total current IT will be 100 over this 14 plus 46 plus J1307. That gives us 3.81 minus J 3.44 ampere. So once you get the current here, total current, you can find the current in this branch. So this branch, that's I prime, will be IT times the opposite branch impedance J4 over the sum of these two branches. So J plus J4, one branch, and other branch is the entire thing. So that will be 23 minus J17. So we'll get it like times 4 plus 4i over 27 minus 13i. So that gives us 0.85 and J of 0.465 ampere. Now V Thevenin prime will be this current times this impedance. So I prime times 20 plus Z20. So I move to polar form, so it will be 27.42, angle is 73.68. This part. Now we need to consider this current source acts alone. So let 1045 ampere source acts alone. So for that case, the voltage source will be shorted, and we do have this. We do have this. Of this, the current source here. We have this, and we have the Thevenin double prime. So this is 20 Z20. This current is 1045. 3 minus J3. 4 plus J4. 10 plus J10. Now, if I want to find the Thevenin voltage, or the voltage here will be the current. We need the current here times the impedance. So we reduce the circuit. Here we see we have two impedance in parallel. And so you can find 10 plus J10 parallel with 4 plus J4. So get 10 plus 10I, 4 plus 4I. So that gives us 2.857 plus J 2.857, and that is in series with 3 plus J, 3 minus J3 minus J3, 3 minus J3. So that gives us 5.857 and minus 0.143. So this is the impedance of this entire side and this other impedance. So you can distribute this current between this and this impedance. So if they will be in parallel, right? So if you get this impedance is connected this on this side, there is a current source here, and this another impedance over here. So this circuit will look like this. So this current will be dividing this side and this side. Now I can apply current division law. So this will be the current over here will be the total current 1045 times the opposite branch. Opposite branch is 585 minus J of 0.143 divided by sum of these two branches, 5.857 J of 0.143 plus 20 plus J20. So that gives us 1.787 plus J of 0.19. Now B Thevenin double prime will be I double prime times 20 plus J20. So that gives us, I find the polar form. So this is 50.83. Shift angle is 51.08 degrees. So now the B Thevenin will be B Thevenin prime for both sources. So that is, so we got, for previous case we got 27.42, 73.68, 50.83, 51.08. So that will be 27.42, shift angle 73.68. I change to polar, so that will be 78.87, sorry, 76.87 and 58.96. So we got the Thevenin voltage. Now we need to find the Thevenin impedance. So to find Thevenin impedance, now we need to remove all the independent sources here. So that I remove the voltage source with the 0 volt, that I shorted the voltage source. Then I open up the current source and I look from the terminals AB. So that will be Z Thevenin. So this is 20 plus J20, 3 minus J3, 4 plus J4, 10 plus J10. So Z Thevenin, if you start from this side, then 10 J10 in parallel with 4 J10 parallel with 4 J4, and that will be in series with 3 minus J3, and finally that will with 20 J20. I already compute this before, so like here, no, over here. So I compute J10 parallel this and series this, and we got 5.857. So I still will get 5.857 minus J of 0.143, and that will be in parallel with 20 J20. So if I solve it, so that will be 5.857 minus 0.143 I inverse plus 20 plus 20 I inverse, this inverse. Sorry, 5.857 plus minus 0.143 I inverse plus 20 plus 20 I inverse, shift invert, sorry. So that becomes 5.05 J of 538, or we can find the polar form will be 5.083, angle is 6.078. So this is the impedance. So once you get Thevenin voltage and Thevenin impedance, you can find the Thevenin equivalent circuit. You can get the Thevenin equivalent circuit. So this is B Thevenin. So B Thevenin was 76.87 and angle is 58.96, and this is 5.083, angle is 6.078. Or yes, now if you want to find the ZL for maximum power, so the ZL basically will be the conjugate for Z Thevenin. So that is 5.05 minus J of 0.538. So here this positive J, now it will be negative. So if the Thevenin impedance is inductive, then the load impedance will be capacitive of equal value. But if the load is inductive, then if the Thevenin is capacitive, then load will be inductive. Or you can simply write 5.083 and this angle will be negative 0.78. So in the polar form, this angle will be conjugate, or the conjugate of the this part. Now if you want to find P L max, so it will be B Thevenin squared over 8 times RL, or R Thevenin. So here I use 8 because the values are not given in RMS. So this is given in maximum. So if it is not mentioned in the question, so you should use maximum, and R Thevenin is 5.05. And again you see, when I put B Thevenin, I took the polar form for B Thevenin, and for R Thevenin I have to take the real part of R. This is R. So you cannot keep the polar form magnitude. You have to take R. But here you cannot take the rectangular part. You have the real part. You have to take the magnitude. So just 76.87 square over this. So it is 76.87 squared divided by 8 divided by 5.05. So that gives us 146.26 watts. Now other type of problem could be the RL or RC circuit. So let's say you need to solve as Let's say we have 6 volt here, 4 ohms, 2 ohms, 6 ohms, 5 henries, 6 ohms, 4 ohms, 6 ohms, 10 volt. So to solve, you have to find, that's I, L, T. So to find ILT, you need to find IL0. IL0. So to find IL0, basically you need to solve t less than 0, a steady state circuit. So at a steady state and t less than 0 before the switch open. So just let me redraw the circuit. So it will be here, and I can combine these two. So this combination will be 2.4, 6, and the switch will be closed here, 4, 6, 2, 6, and the inductor will be shorted. So this is short. So this is 6, 2, 4, 6, 2.4, 10. So now you have to find the current here, that will be IL0. IL0 minus basically. Before the switching, so you can write IL0 minus. So I want to find this current here. So to find this current, you can apply whatever method you like. I could use nodal analysis method. So if you apply nodal analysis method, this voltage will be V1 and this voltage maybe, so this is short circuit, so on V1 will be fine. So if you say V1, then you can write V1 minus 10 over 6, V1 over 2.4, V1 minus 6 over 4, and V1 over 8. Just I add these two together and write V1 over 8 equal to 0. So then solve for V1. So if you solve for V1, so we can write it like 24. So if you write 24, so it will be 4 minus 40. So this will be 10, 6 V1, 36, 3 V1. So I got 4, 10, 14, 20, 23. 23 V1 equal to 76. The V1 equal to 3.304 volt. So now IL0 minus will be V1 over 8. So 3.304 over 8. 413 ampere. And this is IL0 minus will be IL0 and also IL0 plus, because the inductor current cannot change instantly. So we also can find IL0 plus from here. Now you need to find IL infinity. So just T approaches to infinity, and this is also a steady state. So for this case, you will get the circuit will be like this. So now the switch is open. So switch is open for 6, 2, 6, and this. So this will be IL infinity. This is 6, this is 2, 4, 6 volt. This is 2.4 and this is 6, this is 10. So as switch is here, this part has no effect on the inductor. The inductor is completely connected with the 6 volt source. You see this is a simple series circuit. So IL infinity will be 6 divided by 4 plus 2 plus 6. So that is 0.5 ampere. Now we need to find tau. So for tau, I took this circuit with this part with the voltage eliminated. So if I eliminate the voltage by a short circuit, so you'll see at loop from the inductor, so that will be the R. So R is 6, 2, 4. So R is equal to 6 plus 2 plus 4, 12 ohms. Now tau will be L over R, and L is 5, R is 12. Therefore I can write the inductor current expression, that is infinity is 0.5 plus IL0 is 0.4 on 3 minus 0.5 e to the power negative t over tau. So t over tau, so you can write 12 over 5 times t, or you can simply write 0.5, and that is negative 0.87 t. Now if I want to find the inductor voltage, so VLT will be L times di over dt, and L is 5 henries, so we have to take the derivative of 0.5 minus 0.87 e to the power 12 over 5 t. So if you take the derivative of constant to 0, so it will be negative 5 times 0.087 times negative 12 over 5 e to the power negative 12 over 5 t. So that will be 1.044 e to the power 12 over 5 t. So that's the voltage. Now if we want to find the draw the current wave shape, so you'll get how we can draw the current wave shapes for inductor over time. So this is time, and this is the inductor current. So inductor current will be between 2 times. So it is for t equal to 0, we know the value. T equal to 0, we will got the value for IL0 is equal to 4 on 3. So this is 4 on 3, and T infinity we got the value like 0.5. So this is 4 on 3 line, 0.5 line. It is not to scale, so if you go there, so there is an exponential change from 0 to this. So this is the current versus time graph. You also can plot the voltage versus time graphs from here. So if you see the voltage versus time, so time, this is voltage, so this will be exponentially decaying from starting 1.044, So let's 1.044 here, and it goes like this. So similarly, we can solve for RC circuit very similar to this. So you need to find you need to solve a steady state for t equal to 0 or less than 0. That means assume your capacitor is like, think about the circuit here, think about this circuit. So if you wanted to solve this, you have to solve for t less than 0 and a steady state. The capacitor is open. So if capacitor is open, you have to find the voltage here. This voltage will be 0 minus, and you see 5, 10, 20, 15, 60. So switch is closed. So now for finding the voltage here, we can apply nodal analysis method. So if we apply nodal method, so here I show the procedure how to find the VC0. Now for t infinity, again a steady state. So for a steady state, now switch is open. So if switch is open, this part will be eliminated from this because capacitor is connected here. So you don't need to care about the other side after the switch. So we need to find the voltage B infinity. So B infinity, again I apply nodal analysis method. So if you write the nodal equation, the V1 minus 100 over 10, V1 minus B infinity over 5, and the current here is -2. And another node is here. So in this node you see B infinity minus B1 over 5, and current leaving is 2. So now solve this, you will get V infinity equal to 95. Now for tau, just for tau, I make the current voltage source short and current source open, and see the total resistance is 5, 10 and 10, 25. So RC will be this. Now we know the value is 95 for V0 infinity, and this is V0, this is V infinity, and this. So if you want to plot this graph, so now you got Vt equal to this. Now It, ICT, this is BC, VCT, and for ICT it will be C times this. The capacitor's value for the capacitor is this, and I did take the derivative, you find this current expression. And if you want to plot this voltage over time, so the initial voltage is 81 and final voltage is 95. So the capacitor starts up like this. So this is the voltage graph over time. You also can produce the current graph. And I also wanted to show you how to write the test. So please watch the next part of the video, and you will see how you can complete the test. So it will be the mode of writing the final test, final exam from D to L. Thank you. Go to My Ryerson and then select the online courses, and if you see the D12 course shells, just inspect the course. Actually your course will be all sections, the final exam will be given in all sections, but now I am showing you only for your class, section 15 to 26. So go to the assessment. As from assessment you go to the quizzes, and from quiz you can see final exam mock test, and here in final exam assessment then quizzes, then you go to the final exam. So right now I show you the preview. So just see the preview here, and the preview, and down there you can see start quiz. Click on start quiz. The, the quiz will start, and you see the first question is showing up here. So if you solve this first question on a piece of paper, and then take a snapshot and click on this so for this case I just type the answers here, or you can skip this, then go to the next page, and here let's say you don't want to solve this question, or you don't know how to solve this, so you can write something here and click the next page, and then click OK. Then you see the third question. This question, let's say you solve this question and you want to upload your class, so click on that button and say you choose the file. So then you upload this. So select the path, upload file, and click on this. Or you can rename your work and then click this, open this, and then add. So click on add. Then you see there will be a box here. In this box, you can write something. So anything you want, you can write there, and then click OK. And then you see that your result is now OK. Now you can submit your quiz. If you don't forget to check this box and then submit quiz. Also submit quiz. You can see what is your work here. That's your work here, and then click done. So Dr. Farah will be discussing in detail about